In this video, we will go over an example of joint variation and an example of combined variation. Now, joint variation is just a different take on direct variation. Remember that direct variation were equations of the form y equals k times x, where k was a constant of variation. So joint variation just means we have more than two variables involved. So we might have x and y and z. In this example, the volume of a cylinder varies directly as the height and the square of the radius. So volume is related to height and also radius. So there are three variables involved. A cylinder with a radius of 5 centimeters and a height 10 centimeters has volume 785 cubic centimeters. Find the volume of a cylinder with radius 10 centimeters and height 15 centimeters. So on this one, we set up our basic or generic equation, and that's going to be V for volume varies directly, so V equals K is our constant of variation, times H height, and square of the radius means R to the second power. So now we use the next sentence to find our value for K, substituting 785 for V, 10 for H, and 5 for R, we get a value for K of 157 over 50. And we'll keep that as a fraction because it's more accurate than a decimal would be, because what you would see is a decimal that you would want to round. So next, since we have our value for K, now we're going to change our equation to the more specific equation. It's not just V equals K times H times R squared. It's V equals 157 over 50 times H times R squared. Now we use that last sentence, find the volume when the height is 15 and the radius is 10. We put that in our equation and we get 4,710 cubic centimeters. The next example is what's called combined variation. And combined variation means we have some variables that are directly related and others that are inversely related. Remember, direct variation was y equals k times x, so there's multiplication going on. Inverse variation was division, y equals k divided by x. Vanessa Jones has determined that the number of children enrolled in her daycare center varies directly with the amount she spends on advertising per year and is inversely related with her weekly charge for each child. This year, she spent $900 on advertising, charged $150 per child per week, and has 51 children enrolled. Next year, if she spends $1,000 on advertising and charges $170 per week, how many children should she expect to enroll? So we start off by using the generic version of our equation. Now, since our number of children is directly related with the amount she spends on advertising, we would expect the number to be equal to K times the advertising amount, but it's inversely related with her weekly charge, so there should be a dividing by the weekly charge. And that's what we see here. So N is our number of children, A is the amount of spent on advertising, and C is our weekly charge. So here we have a direct relationship, N equals K times A, and we also have the inverse relationship, K divided by C. Notice that there is only one constant of variation. Now we're going to substitute given values for N, A, and C. So 51 children, I spend $900 on advertising and charge $150. So now we have a K value of 8.5. Using that K value, we now have the specific equation. The number of children is equal to 8.5 times the amount spent on advertising divided by the cost or the charge. What's the number of children. If I spend $1,000 on advertising and charge $170, I can have 50 children.